Hey guys, today's lesson we're going to talk about correlation coefficient, and that is a new vocabulary term. We've talked about correlation. Correlation is the relationship between two things. So we've talked about positive correlation, negative correlation, and no correlation when referring to scatter plots. And now we're going to talk about a correlation coefficient. And we've heard of the word coefficient before. Coefficient is the number that is in front of a variable typically, but now when we combine it with correlation coefficient, we're talking about the letter R. That's the symbol that we use, and it measures the strength between two data scores. So a couple things that you have to know. If your R value is between 0 and 1, okay, so greater than 0 but still less than 1, then you have a positive correlation. So if R is a positive value, smaller than 1, it's a positive correlation. If R is a negative value, so if it's less than 0 but greater than -1, it's a negative correlation. The closer it is to 1, the stronger the positive correlation. The closer R is to -1, the stronger the negative correlation. If it's close to 0 on either end, it's going to be weak. And if it's equal to 0, then no relationship exists. So to give this a little bit more meaning, if I give you that the R value is 0.98, okay? 0.98 is really close to 1, and because it's positive, it's going to be a positive correlation, and because it's close to 1, really close to 1, it's going to be a strong positive correlation. Now, if we have an R value that is negative 0.21, well, if it's negative, we know that it's a negative correlation, and because it's more close to 0 than it is 1, or 0 than it is -1, then it's going to be weak. So this one will be a negative, weak correlation. We were also told that if R is equal to 0, then no relationship exists. So another way that you could write that is that there is no correlation. And on the other end of the spectrum, if R equals 1, or if R equals -1, then that would be a perfect correlation, either perfect strong correlation for R equal to 1, or a perfect negative correlation if R equals -1. And what that scatter plot would look like, it would be a perfect straight line with those dots lining up ever so perfectly. Okay, so now we're going to move on to the next part of our notes, and we're talking about and it says in the last few lessons we have worked with generating lines and curves of best fit for bivariate data sets. Remember, the word bivariate means that there are two things that you're comparing. In every circumstance, though, the data did not fall on a straight line or on a perfect curve. We have never answered the question of how well specifically a linear model does in predicting the correlation between the two variables. Now, exercise 1 says that your teacher will explain how to ensure that your calculator has its R value on. Now, in class I would tell you how to find the R value with your graphing calculator, but being at home now, I know that we don't have graphing calculators at home, so we're going to wait to go over how to do this on the graphing calculator once we come back to school. So for now, I'm just going to give you the R values in exercise 2, part A through D, and then we'll talk about kind of decoding that and figuring out what that means in each circumstance. Okay, so Again, normally we'd have to do this on the calculator, but we don't have a calculator. So, in exercise 2, in the following exercises, 4 data sets with equal x values are given to illustrate different types of positive correlations. For each, enter the data, observe the scatter plot, and record the R value known as the correlation coefficient for a linear fit to the nearest thousandth. Okay, so the first one, when you do all the stuff on the calculator, you're going to get an R value of 0.999. Now, this R value is extremely close to 1, so when you do have your graphing calculator and you type this in, your graphing calculator can also show you the scatter plot of this data, which is really cool. And this particular scatter plot would have a very, very, almost perfect straight line with the dots lining up. Because this value is extremely close to 1, so it's a strong positive correlation on this one. Now, part B, when we type these values in, we're going to get an R value of 0.957. And this one is also a strong positive correlation. It's obviously not as strong as the first one, but it's still very strong. And when you look at the scatter plot, it's going to look like a pretty close to straight line with your dots lining up. Okay, on to part C and D. So in part C, your R value that we calculate is 0.776, which is still a positive correlation. It's not as strong as the others, so we're going to call this, I would say, a moderate to moderately strong positive correlation. So it's not the strongest, certainly not the weakest. It's more than halfway, closer to 1, so it's still moderately strong, and it's certainly positive. Now in part D, the R value that we get is 0.133. Still positive, but this is closer to 0 than it is 1, and this would be a strong or a weak positive correlation on this one. Now in part D it says, how does the correlation coefficient, again they're saying how does the R value, quantify the fit of a positive correlation? So we're only talking positive here, and quantify meaning like how do you put it into numbers to make it make sense as far as how strong or weak the correlation is when it's positive. So what we're going to say is the closer R is to 1, the stronger the positive correlation. Exercise 3 says the following data set is that of 2 variables that have a negative correlation. Enter the data, produce the scatter plot, and record the R value. And then, how is the negative correlation reflected in the R value? So when we type this into the calculator and we get an R value that is negative 0.945, we know that since it's close to negative 1, that it's going to be a strong negative correlation. And it says, how is the negative correlation reflected in the R value? Well, since it's close to negative 1, that's why we know it's a strong negative correlation. So that's what. And now we're flipping over to the next page of our notes. So exercise 4 says, given the scatter plot shown below, which of the R values would most likely represent the correlation between the 2 variables? Explain your choice. So after you choose which of those 4 options would be the best R value to represent the data, you then have to explain your choice as to how you know. So if you look, this is clearly a positive correlation, which means that we can eliminate choice 4 It is not scattered all over the place, so it's a pretty strong correlation, so it can't be choice 2. Choice 2 would be more scattered because it's weaker. Now, it's not a perfect straight line, so it can't be choice 3, which only leaves choice 1. And our explanation in why we chose that, aside from process of elimination and logically thinking through, is that we're going to say it's a strong positive correlation, but it's not a perfect line. So by saying that it's a strong positive correlation, that eliminates choice 2 because it's not strong, and it eliminates choice 4 because it's not positive. And then by adding in it's not a perfect straight line, that will eliminate choice 3, and that's a perfect explanation as to why it's choice 1. Okay, exercise 5. Which of the following scatter plots would have a correlation coefficient closest to -1? Now, we don't have to explain this one. So if you look at your options here, if it's really close to -1, then it's going to be a strong negative correlation. Now, choice 1 is positive, so it can't be choice 1. Choice 3 would be more of a no correlation option. So now it just leaves us between choice 2 and choice 4. Both are negative correlations, but the closest to -1 would be the one that looks closest to a straight line with a negative slope. And that would have to be choice 4. Okay, on to the last question. Exercise 6. So we have that there are 2 primary types of crude oil sold in the world: West Texas Intermediate, WTI, and Brent crude. Each is priced differently on a daily basis, and each has a correlation with the average price per gallon for unleaded gasoline. The 2 linear regression models, along with their R values, are shown below. Give a prediction for the price per gallon of unleaded gasoline Y on a day when the price for WTI is $103 and the price for Brent is $109 X. Which model did you choose and why? Okay, so we'll start with Brent. They told us that Brent was 109 as the X that we had to substitute in. So what we're going to do is we're going to copy down this formula, but instead of writing X, we're going to replace that X with 109, sorry. And don't worry about the R value at the end for now. And when we figure out what the Y value is, it's going to give us $3.76. And the Y value represents the price per gallon of unleaded gasoline. So the price per gallon of unleaded gasoline at Brent crude is going to be $3.76. Now we're going to do the WTI crude, and they told us that the X value here that we're substituting in is 103. So we're going to copy down the original equation, but instead of X, we are replacing X with 103. And when we do the math, we're going to find that the price per gallon of unleaded gasoline at WTI crude is going to be $3.86. So they're asking, which model did you choose and why? So which one are we going to choose? And before you make your decision based on price being higher or lower or anything like that, obviously the choice that we usually want to go for is the cheaper option, right? And on top of Brent crude being cheaper, it also has an R value that is closer to 1. So Because the R value is closer to 1, this is actually a better model, and it's a better predictor that Brent crude has accurate pricings. So that is why we're going to choose Brent crude. So my final answer for which model I chose and why again is Brent crude, because the correlation coefficient is closer to 1, so it's a better model and a more accurate prediction of the price per gallon of unleaded gasoline. And that is going to conclude our notes for today.